new series of technology, tools, and programming languages. Step-by-step instructions for any beginner for a specific tool or programming language that would give you a good crash course. Where to begin, how to quickly adapt with a strong foundation. We will cover the most popular and difficult aspects of many tools and languages as we go. Today, we will cover Rust programming language. This session is with a Malaysian programmer where I am the mentor and clearing the doubts. Since the content is too long, hence I have divided it in parts, else the video would have been too long. So, let's get started.
All right. So last week we discussed concurrency, but just to quickly, reiterate what we did. Concurrency is basically any process that is happening in parallel. That means we have different tasks and they might execute at the same time. Now there could be
Mm.
a little bit pause, there could be the same data, or it could be a lock on the data. It could be multiple scenarios, but broadly the
But
concept of
yeah. But last week you mentioned the priority, right? I see.
Yeah, so we will come to that also. But main thing on concurrency is any task that is happening parallelly is basic concept for concurrency.
Okay, understand.
Yeah, and to achieve that or how you do that programmatically is by creating threads. And when we create threads, then that concept comes that whether the thread will have priority or we will use lock to it or different ways of using thread through our program so that we can achieve multiple things where it's concerned to multitasking or multi-threading, right? Is it anything you
Both
want to ask?
multitasking and multi-trading is concurrency. Both
Yes.
multitasking and multi-trading also belongs to concurrency subject, right?
Yes, exactly. This is actually the broader subject is concurrency, and if you go deeper into it, that's one is multi-threading and the other one is multitasking.
Yeah, I think I heard I studied this before. Yeah,
Okay.
this one in
Yeah,
Java
great.
also the same.
Yeah, exactly. The concept for all programming languages, if it comes to concurrency or threads, is the same. So any language,
Okay,
any programming language has threads. It will be the concept will not change. The only thing that will change will be the syntax that you're using, or there could be additional features or less features within a programming language. So
okay,
only that could change, or maybe the name could change for some programming language. It could be named something different, and for Rust, it could be different. That's the only thing. Otherwise, everything, the concept, basic concept will always be the
okay.
same. And how we create thread in Rust, this is obviously different from the other languages. We create a thread using thread colon colon spawn. That is the function that we use, and then put the code in the parameter, create a function, and then pass it. So just let me show you the code which we discussed last time. Just have a quick look and let me know if you have any questions on that, because we did it in the last
Uh,
session.
no question actually. This one I know. The
Okay.
reason why my second homework not done because I facing the mutable reference problem, and then is the second homework, if I'm not mistaken, is two of the thread try to update the variable from keep adding it up, and when I share the variable, it's like telling me that the variable uh somehow can't share for some reason. I need to take time. I think it should be the break the rules of ownership or reference maybe. Yeah.
Okay. So for
So
that,
what
it's
I did is I put a global variable and then try to use these two threads to override the global variable, which is not correct, I think.
okay. So for that, maybe because if we discuss it like this, it will be difficult for me to figure out what's the issue. Probably it's better
Yeah,
if
yeah, yeah, yeah.
maybe you can share your screen or share the code with screenshots. Just create a new document in that shared folder, copy that code, and with screenshots what problem you're facing. That is one way, or maybe in today's session, end of session, you can share your screen, quickly show me, and then I can figure out
Uh,
what's the
I
problem.
I think I can do it because I spent what yesterday night I spent a whole night to study ownership and reference again. Now my knowledge is much better.
Okay,
Yeah.
that's
So
good.
I think I can do it because sometimes it's just a fundamental concept. Sometimes you cannot like mutable or not immutable, or like the scope, the lifetime already end or something like that.
Yeah, exactly. I mean, if it's not able to use it, then it's only the scope of the variable
Yeah, yeah, yeah,
that's a possibility. But
yeah,
every time it's not theoretically, you have to practically, implement the code and see what is happening. So you have to
yeah.
balance it both ways. So if you still struggle on it, just share the code in a document and I'll have a look. Or you can do it in the session also, next session when we have, you can share your screen and I'll go through the code and help you fix it. You can do anyways.
Okay, can I try it. Next time is, let's say I fail to do it, then I'll tell you.
Yeah, yeah. You can create a document or a video also, sharing your screen, create a
Yeah,
video and
I
show the code where the problem is coming, and then we can come up with
understand.
a solution.
Okay.
Okay. So this code for threading is fine, right? The next concept
Uh,
for it was
yeah, we can move on.
okay. So the next concept was thread sleep. Can you tell me quickly what it was? We've already discussed, so probably we will.
Trap C is a delay, delay for delay for certain second. Depends on the input you push in. You delay. Uh, the input should be in millisecond, I guess. So something like that. So you slow. You stop temporarily stop it, and then allow other thread to process.
Yeah, exactly. So
Something like
when we want parallel processing, what we do is we ask the thread to sleep temporarily, and how much time it needs to sleep is by giving it a millisecond value that is passed in that sleep method. Why this is in milliseconds? Because it could be, the pause could be only for 1 millisecond. Also, that's the smallest unit you can pause a thread for. So that's why it is in
that.
milliseconds, and the larger could be even whatever minutes or seconds you want it to. So
Okay. But actually, trading is very rare to you. When when I started learning trading in Java, then I just stopped there, and then after working for 10 years, actually not really using trading a lot. Maybe I'm not a gaming programmer. I heard they are the game programmer. They actually use a lot of trading.
no, it's not that. See why it is not exactly used as you write a thread or create a thread, because uh, initially when I used to program, we created threads and we had to handle that. But gradually, so many frameworks came up. I
Or
don't know
they
how
helping
many.
it. I think the framework is helping programmer not to use trade,
Yeah, so
because
it's
the
not about.
framework.
Yeah,
Yeah,
it's
the
not.
framework itself handle it for programmer already, so program become lazy or something.
Okay, so it's basically, what happens. It's not only about gaming. It's so many softwares, or even so many development websites that we create for investment banking or e-commerce portals or so many others.
Mm.
If you see at runtime, if you see that payment system, even that has a threading concept behind it. But how that's
Okay, okay.
handled is, we don't create a thread itself. Why? Because we have so many frameworks coming up, whether it's Java or their other programming languages. These frameworks are handling that threading on its own. So we don't need to
Yeah,
do that specifically. But if as a programmer we don't understand the concept behind it, then we can't understand the framework also. Because
understand. Okay.
framework is largely providing you the interface to build it, but then the logic behind is how it's functioning,
Maybe,
we need to understand that, and if we don't understand that, then it's very difficult, right?
okay, okay.
So
Yeah.
how so many users are handled at one time, when a e-commerce website, when everybody is purchasing, say for one single product is being purchased by thousands, maybe at a single point of time, it's all threading that's handling. Now
Okay.
how that's handled, definitely it's the framework that's handling. Behind the scenes it's happening. And if we
Okay.
don't keep a pause on one purchase to the another purchase, then it can't be possible, right? So practical scenario,
Yeah.
everywhere, every execution, every user login, all is threading. So
Okay. Okay.
and any task that's multifunctional, or happening in parallel. So e-commerce is a very big
Mm.
example of execution of parallel processing, right? So
Okay.
So you
Yeah,
have
yeah, yeah. Like the website, we got 10,000 concurrent user, and then everyone use.
exactly. So that is all threading only, and like again, that's broadly a concept of concurrency. And if the concept behind is the same, but it's handled by the framework. We don't have to create the threads on our own, or the programmer is not to create the thread for that
Okay, good,
part.
good. Yeah, understand.
Okay.
Yeah, actually,
So
I whatever you speak, I type down so I can my concentration is better. Sometimes if I don't type, then I might think other things. So the words that you say, I actually type it.
okay. Yeah, that's great. I mean, because you can catch up those words and then find out more on it with those words.
Yeah,
Yes.
yeah. So roughly, I actually write down actually whatever you say, the
Yeah.
sentence words by words. Yeah.
Okay. Okay. So then again, this concept of join, where we can join multiple threads and help it execute as one. If you remember, I showed you two programs, one with without joining and the second one with joining, and the difference between the two. You remember, or
Yeah,
you want me to show it
I
again?
remember. I remember. Okay, the thread that having joined. Okay, maybe I think I still remember the first thread is like 1 to 9, and then second thread is like 1 to 5. So,
Exactly. Yeah.
yeah, obviously one thread has running more time. How to one thread is running more time than the other, but how to combine both together though, using join actually.
Yeah, we can use the join method and then combine the two, and this was the code for it. So
Okay,
right, so here in
I
this
understand.
line you see we've joined, which means we are joining these through threads and they will execute as one thread. So both will execute, and only then the program will end. Otherwise what happens is main, now here the I taught you the concept of priority that you were saying. When we
Yeah,
are executing two threads, either as a programmer we set what is the priority for which thread, and accordingly the program will function. But here main as a function is also a thread, and then main will always take priority. So if the execution of code in main ends, then the rest of the code will not execute.
yeah, yeah. So let's say first thread 1 to 9, second thread 1 to 5. If the priority is the second one, then the 6, 7, 8, 9 for the first thread won't be executed.
Won't be executed, right? And if you don't join it, then also the same case, if we join it, then all will execute because it's working as a one thread now.
So if join, then yeah, yeah. If join meaning two thread become one thread, right?
Exactly, two
As you say.
threads will
Okay,
become
okay,
one thread. Yes.
okay, okay. No wonder can it execute everything. Yeah.
Yeah.
Okay, okay.
Okay,
I get it.
so after that we had a multiple ownership, or a state of concurrency that is shared. So multiple threads can access that same memory location, and where we had the concept for smart pointers. And you remember we discussed smart pointers where we can store the data on heap.
Yeah, yeah, yeah.
Okay, so
But counter is like box.
exactly, smart pointers where we created box. So for that, in case of threading, why it is created with smart pointers is because at runtime, maybe for a certain thread, you need the memory allocation to be done at runtime and not at the compile time, and that's when you use smart pointers. Otherwise, you won't.
Yeah, because the size is dynamic, right? So you need a heap rather than stack.
Yes, exactly. So if you want the size to be dynamic, it has to be on heap. It can't be on stack. So
Yeah, yeah. But heap is slower. Yeah.
no, it's not slow, but yes, you have to handle a lot of things when it comes to heap in terms of memory management. But in case of
Okay.
stack, you don't need to handle that. That's why Rust has given this option that you can do it at stack, because then the programmer does not need to worry about memory management. But whenever
Okay.
you are storing any data at heap, you have to worry about memory management.
Okay. Okay. Understand.
Okay. Then I also covered this, right? I covered mutex where we are creating a lock for a thread, and so that at a time the data access can be only for one program or one thread, and multiple access can't be for that same data. Do you remember that?
Uh, this some text or can you repeat? I remember, but I don't remember the what when we should use mutex.
Okay, so when we are using mutex means that only one thread at a time will have access to the data, and the other thread will have to wait until and unless that lock, it kind of
Yeah,
creates a
I
lock to
think I,
that thread.
then now I understand. It's like two threads try to access the same function, and the mutex only allow one thread to execute it at a at one time, right? Something like that.
Yeah, okay. Yes. So let me give you a real time example again with the e-commerce, because everybody of us, we keep purchasing, so we know e-commerce in real time. So imagine that two people are trying to purchase one same phone at the same time, and there is only two in the stock. When while one is purchasing, there will be a temporarily lock on that purchase. Until and unless that purchase happens, the second user will not be able to execute that purchase, and that is in that pause or that gap is for such a few milliseconds that we don't even come to know as a user. Sometimes you might have seen that that same page takes you to check out or to
Yeah, yeah, yeah.
make the payment for a
Sometimes you
longer time,
yeah
and
yeah
sometimes it
sometimes you
happens.
check out, but then it shows that, but when you try to purchase it, it's like out of stock, something like that.
Yeah, it's not in stock. So there can be multiple scenarios. There are unlimited permutation combinations to that situation. But yes, at the background, it's again multi-threading or the concept of lock for a particular data. So this is a very small uh, example. But yes, that is the case where we use mutex and we put a lock to that data, so that the second user, when it comes, it will only see the updated status of that data.
Okay,
So that
understand.
that is where we use mutex, which will put a lock, right? And that lock is
Mm.
very temporary, only for that limited time where we are executing that particular code. So for this example, this code, only this piece of code has lock. So only for this particular time there will be a lock. After that, there will be no lock to that threading or any mutex that we create.
Yeah, I got it.
Is
I
it clear?
understand.
Okay.
Yeah, it's understand. After you explain, I understand.
Okay. And for any mutex that we are creating, we have to keep in mind a little bit of concepts. So one is a smart pointer called mutex guard that is wrapped, and one is the lock result. So these are few theoretical concepts that right now I won't explain. If you can just see this page, maybe just
Okay.
read it after the session, and you can ask me any questions on that. It's very theoretical. Practically we will not use it much, but yes, we should know, because this is something that might happen at the back end. So as per concept, we should know it. So why we are using returning a smart pointer called mutex guard, why it is wrapped in lock result. So all of this, just read it through and then let me know if you have any questions
So
on it.
mutex guard and log result. Okay, I understand.
Yeah, and maybe you can just Google and have a look at more wider concept on that. But it's only for theory purpose, not something
Good.
that we
Yeah,
will
I
use.
understand. Theory purpose.
Yeah.
Okay,
Okay.
I get it. Okay.
All right. Then how we are going to share mutex with multiple threads. So this is again a very real time concept, that we are going to have a same mutex for multiple threads, which mean multiple threads will have that same lock, which means that you have a transaction right from when you add your product to the cart, and then you check out, and then you make the payment, and then there is a page that shows you that the order has been placed. So it is a series of thread basically. And if you
Just I mentioned Siri of trade. Siri.
ser-
Siri.
series, that means multiple
Oh,
threads,
series. Ah,
or
okay. Yeah, yeah, okay,
a
understand.
transaction, a multiple transaction, multiple set or series, or anything that is happening step by step but has to happen at one go. So if anything breaks in between, the transaction won't happen successfully. So that is called a series or a transaction in real time.
Yeah, I think. Yeah.
And in that case we will use mutex for multiple threads. So it means a lock on that transaction or on that series for that multiple threads that we have created. So one thread will be for say add to cart, then there will be another thread that will be to checkout page, and then the third one will be to make the payment, and fourth will be the exact payment, and the fifth will be to show the screen with the payment order placed. So these are like 5 6 steps that happen when a user is purchasing a product, and we need multiple threads for that and a lock for it, so that nobody else, no other user can come in and purchase the same product, and there can be discrepancy of two people buying the same product. That should
Yeah,
not
the
happen.
this one the word you using lock, right? LOCK, right? I think it's the need to.
Yes, LOCK, which I covered for mutex. Wait, let me show you this.
Oh
So
yeah, yeah,
here
yeah,
we
yeah. I
created a
because I
mutex.
yeah,
Okay,
okay.
so this is the syntax of how we created a mutex, and this is the lock that we create for that mutex, so that no other thread can access this data. This number that we've created, no other thread will have access until and unless this lock is present.
Yeah, the day I think you mentioned before the percentage num is the different dereferencing, right? This line.
No, the question isn't clear. What are you saying? What I mentioned?
Uh, you see the line. Okay, you highlight two lines, right? The li- the second line percentage is dereferencing. Right? This one not percentage. Sorry, asterisk num.
So it is
What is
basically
asterisk num?
multiplying the number with itself.
Oh, I understand. This one is
Okay.
num
So
equal to
star,
num out.
yeah, star
Yeah,
in
this
any.
one. Yeah, yeah, I understand. Okay, now I understand. I thought it's a dereferencing. Dereferencing also using this command, right?
Referencing we use ampersand,
Okay.
and star means any programming language or any for any
Yeah,
system, if you see, star is for multiplication, and
I know. I understand now. Let's say the num come in front, and then the asterisk is behind, then different meaning. I think. For this one is num equal to num multiply by 6.
yeah.
But let's say num come first in front, and then the asterisk after the m. I think it's different meaning. Yeah, yeah. I get it.
Okay, so any other question on that?
The day you mentioned the colon, sorry, the colon and question mark. I think I forget already. The last
this
line,
this
ah
one.
the colon and the question mark.
Okay,
What is
so
the meaning again?
this was not last time actually. I think so 2 3 sessions back you asked me
Oh,
particularly that. So how to
yeah,
refer
yeah.
this m value? What will be the m value? This is the syntax for referring that. So it will be m
Oh,
equals to what value of m to print here. That is why we use colon and question mark. So it is
let's say I don't
simply a
want.
text.
Let's say I don't want question mark and colon. Is that okay? It's working fine, right?
Okay, so I let me give
Uh,
you the homework, otherwise you will keep
okay,
getting
lah, okay.
confused. And I think so I gave you one homework on this also. To
I think I
write
forget
one
already.
with
This one is should be a simple thing, but then
yeah, it is a simple thing. Okay, so let's
mm,
give you homework. Write two programs,
okay,
two different programs. One where you are using two data types, which is printing the value without using this colon question mark, and the second one will be where you're printing the data with using this colon and question mark. What is the difference between the two? You find out, because when you find out, you'll learn better. If I tell
okay,
you,
okay.
it's again repetitive, but you won't
Yeah,
remember then. So for you to
understand,
remember, write a code, and if once you write a code, you will never forget it. I told you about multiple threads, right? A mutex on multiple thread, and a real-time scenario also we've covered for that.
yeah, trade, join, spawn, all this.
No, a real-time example for why we need a mutex for multiple threads. Can
Yeah,
you
you just now
reiterate
mentioned
that?
the e-commerce, right? Just now you mentioned e-commerce, right?
Yeah. So can you
E-commerce.
explain why we will use a mutex on multiple threads?
Yeah, because the thread always need to execute a common function. Uh, and both of them cannot interact at the same time. So it's like there will be an order there. So and then you mentioned the mutex guard and the log result, which is the function not very frequently used, but need to know for some to know the theory. Yeah, I think you mentioned this.
No, theoretical, I told you this part. This is theoretical. So this is only for theory. You can read that later. But this is
Uh,
a real-time scenario where we need a mutex for multiple threads. And I gave you an example of the e-commerce website. So
yeah.
what is mutex? First of all, let me just quickly reiterate that. Mutex is a kind of a lock on multiple threads. Now, a
Or
real-time
lock
example of
or lock. Okay, okay, understand.
Okay,
Yeah.
so why we need that lock on multiple thread execution is a very real time example of e-commerce website. Two people
Mm,
purchasing the same product. So right from selecting the product to the end purchase, we need a lock to that entire process or entire transaction or entire series. If we don't have a lock for that, obviously two people end up buying the same product, which we don't want.
mm,
Is that clear?
understand. Yeah, yeah, yeah. So you need to make sure one go first and then the other waiting for the first one to
Yes,
be
so one
completed.
transaction should end first and only then the second user will be able to make the purchase.
Understand.
Okay. So this is a code for it. Let's simple. So we're using two packages. One is the sync mutex and the other is simple thread. Creating a counter for that mutex and a vector also. And then
Counter is
this is
heap driver.
no, it's
Mm.
uh, not a heap. It's basically a macro, so it will be on stack if you see.
Counter is
And
in heap, right? You got new keyword.
no, so okay. For counter, it's fine. We are creating a mutex here, so we have to use new. But for vector, okay, I thought you were saying for vector. So
Okay,
vector,
okay.
it is on a stack. Okay. So try to understand. One, we created these two variables. Then there is a for loop, which is till here. And what we are doing is we are creating a lock on this thread, the first one.
I read the code. I know what it means that the okay there are 10 threads I think and the looping is like uh making them like eh, lock. So making so yeah actually basically is make it like one thread waiting for another while you add the you add num by one. So after that you join together. So you actually combine all the thread together and then you get 10. I think this is like my second question. A second homework, right? The homework the question is quite similar. The homework is
Oh.
like they're asking to sum everything and then this one looks like that.
Okay, so you
Yeah.
got the answer for your earlier homework.
Yeah, it looks like the answer.
Okay,
Yeah.
that's good.
Uh,
Okay, so yeah, you can
but this
take
one
that
do
from.
it I think this one do it in an uh advanced way because my homework we are not using vector. This one is
It's
like
it's
because this one you
okay.
got lock. This one you got lock there, and then that time I think I don't. I without lock, I think can it be done? I think also.
See, there can be multiple ways of doing it. There is no fixed hard and fast rule that you have to do it in this way or that way. Because right now we are just understanding the concept of lock. We are not actually doing any transaction that we really need the lock. Right, so you can use vector, you can use any other data type, try to use some other data type, it's fine, it's not that you have to do use vector. But right now the log concept is just to understand, because I don't do you see any transaction that we have to necessarily have the log? No, it's not. Try to understand the code and yeah, let me know if you have any questions on that, because that was a part of your homework, so maybe you can do it and see if it's working, and if you have any questions we can discuss in the next session. Is that fine, or you have something else to ask?
Yeah, no, you can skip this.
Okay. Um okay, after this we have a concept of a smart pointer, basically used in multiple threads, which means a
Mm.
multiple ownership with multiple threads. That same data can be accessed in multiple threads, and that's why the ownership will be transferred to all the threads.
Yeah, but
But
at the same time, only one person can own one thing, right?
yes, at a point of time only one person can use it, but there can be multiple ownership. So multiple threads
Multi,
will
multiple transfer, multiple transfer. That's what you say.
Yes, multiple transfers or multiple ownership for that same data across the threads.
Okay.
Okay. And how we do it?
Transferring ownership will cost memory a lot, right? Is it?
Yes, it will, but we have to do it in case we have multiple, threads accessing the same data. And in real time, that has to be done a lot of times. That you have to use that same data. Any transaction across, whether it's through a payment gateway, where you're purchasing anything online, there is a transaction. Then there is a series of records to be updated. Maybe you have a system where you are updating the salary of all the employees. Now a company might have 1000 employees in its company, and you want the salary to be updated, or name and the payment is to be processed for all the employees at the end of the month. So there has to be a transaction for all this data. There has to be multiple threads accessing that same data at a point of time, right?
Mm.
So the
Okay.
transfer of data or the access of data has to be done. So this
So
example.
multiple access meaning multiple reading, multiple updating, or something like that.
Exactly. Uh,
Okay.
this is one scenario. It could be possible that there are multiple threads, multiple data, but single execution. Then again, there could be some scenario where there is one data, multiple threads, and then single execution. So it can be a lot of permutation and combination, depends on what we need to achieve or what we need to code. It all depends on
Okay.
the requirement. But right now we are just doing very simple basic code to understand. That's it.
Okay. I get.
Okay, just read through this code and let me know if you have any questions. It's simple. Again, concept of threading, having a lock, and multiple access to the shared data.
Yeah. There's a one word called move, right? It's a keyword, I think. There's no variable named move. So line 12.
Yeah.
Like how you
So
see the word move this move is a keyword, I think.
yes, it's a keyword where you are actually this will be used only in thread where you are giving multiple ownership to multiple threads. So move
Mm,
will be giving ownership for this thread to some other thread for only this part. So the limitation to this ownership will be from this curly bracket to this curly bracket. After
okay, I
that, the
understand.
ownership will not remain.
Mm,
Okay.
okay.
Any
Yeah, yeah.
any other question?
No.
Okay.
This
Great.
one not hard lah. I assume push is a function for vector, so I don't ask.
Yeah, and
Should be
moreover, I don't want you to get into much of coding for threads because right now we have frameworks, and even in Rust we have frameworks. So you will not necessarily code all this. So for a coding perspective, it's not that important. But yes, to understand the concept, it is very important because behind the scene, every framework is doing this. So
mm,
don't maybe write the code, but then make sure you understand each and every concept behind this whole concurrency to all the details that it has,
mm,
and how
understand.
it is, and how this thing is used in real time. That is also very important.
Okay,
Okay.
I get it.
Okay. Now again, there's another concept as atomic. This atomic
Mm,
is basically a situation where we have a safe use of data in multiple scenario, or you may say that one data type or one primitive data type is used concurrently or used multiple times. So if you using
data
that,
type, data type. What you say?
yeah, data type. Data
So
type.
meaning is like data type means integer,
Yes,
float.
yes, yes.
Oh,
So
okay.
any data type, any primitive data type basically. So for that concurrency, you see this line, atomics are an additional kind of concurrency for primitive.
Yeah, look like generic or something like that.
Uh, okay, so this is basically when we are giving the data types also the what do you say usage for multiple threads, and that's when we will use atomic for these data types for concurrent situations only. So in case we don't have a concurrent situation, we will not use it. Okay.
Okay. I get it. This one is like sharing data type. But sharing data type is that important? I'm thinking.
Yes, it is very important. There is like there are n number of real time scenarios for sharing
Yeah,
data.
yeah, yeah. The 10,000 time and then you don't want to declare
Yeah, and
10,000.
that too multiple access, multiple users. Even when a user is logging into a website, that is also a multi-threading concept only. How is it handled? Like you sign in to any website, say for freelancer only. You sign in through the website, right? So it is like multiple users accessing the same website. So that is also a concept of multi-threading.
So this one is called atomic concept.
Yes, so for data types, when we want that data type in concurrent situation or maybe in threading, then we will use atomic data, right? So this will be two package, and you can also go back to the session and listen to it, and then maybe uh, write whatever questions you
Mm,
have, or the keywords that you are noting down. Okay, for now maybe you
mm.
are just so that you can focus. Is it?
Sorry,
You're writing
what
down
do you
so
mean?
that for now you can focus, or what is it?
Yeah, whatever you say, I roughly get the meaning, and then I just type what the words coming from your mouth. That's why I concentrate better.
Okay.
But if you read what I wrote, it's not a complete sentence. It's just a randomly whatever you say, then I just type something. Yeah,
Okay. Okay.
and then
Okay.
of course Google Meet is a better. Your voice is very clear.
Okay, so
Google Meet is better.
we'll use Google Meet only then, and I also use the PPT on the same browser, so we don't have to switch browsers then.
Yeah, yeah.
That I saw as a limitation with Google Meet.
But when you talk in Skype, your voice is like cut out, and then sometimes
Yeah,
I can't
maybe
hear.
I've used Skype after a very long time for calling. Otherwise, currently most of the times for any calls we use Zoom only most of the times, and
But
in rare
Zoom got
cases I use
45
Google
minutes.
Meet.
Yeah,
Yeah,
Zoom got
so
45 minutes.
normally in my case, for my end I have not taken a purchased version, but yes, for the meetings that I do with other people, they have a purchased version, so it doesn't get a
Okay.
problem. So, but then Zoom is the best quality for now if you want to really
Yeah, yeah.
do any sessions.
They actually they are the only product of the company. I think
Yeah,
Zoom
that's
company.
right. Yeah, and
Google got a variety of products. That's the reason.
exactly. And Google Meet is just one, one small product of theirs, and they don't even focus on
Yeah,
it. So that's why. And
yeah,
Zoom is individual product, and that's why they focus so much on it. That's
yeah,
why
yeah.
maybe the quality is good on Zoom.
Mm,
Okay.
yeah.
So this is the code for atomic use. Just quickly browse through it and let me know if you have any questions. And
Okay. This one right? Eh? Are you sure it's this one? This one is like the previous one. The same thing.
no, no. See this part. We've
Slightly
created
changed.
an arc
Oh,
counter.
okay, okay.
So
So the atomic syntax is ARC, right? Atomic
yes,
is
yes. For atomic, we will use AR colon colon clone, or if you want to clone, and if you don't want to clone, then you can use something else. But for this is
ARC. What is ARC short for? ARC?
yeah, this is ARC is for when you want to create an atomic use for any data type.
Oh, okay,
So
okay.
this data type is in this case is we've used a counter where this is an object on
Uh,
mutex for atomic data type. We've created an instance for it, and then we are using it here in the thread. So
I
basically,
checked from internet the ARC called atomically reference counted. Yeah, I think I understand this one. So meaning this like uh actually basically this one counter you don't need to declare counter. I think you keep updating the same variable counter rather than destroy the counter variable and then regenerate it again. I think.
yes. So it's basically updating the value of this number, adding
Yeah.
one to it multiple times.
Mm,
So that's why the plus sign. So whenever you add a number to it in the counter, it will keep adding to the same number. Right?
okay. Yeah, you're right.
Anything else?
No, nothing.
Okay. Then let's move forward. I'll just quickly cover this concept and then maybe end the session. Rest of the slides, just
Okay.
quickly check last two slides. This is all theoretical. So, just read through it and then ask me any questions because it's very basic concept. When we come to the part where we will start covering the frameworks, this all will happen behind the scenes and then we don't need to worry too much, but just understand the concept and that's it. Okay. So
Yeah, this one riffs. Yeah, I don't understand the ref cell. Yeah.
okay, so reference cell is when you are allowing mutable contents or the mutable instance that you've created of a data type, you are allowing that through the reference cell. Then this concept of reference cell will come and mutex will be a lock on that data type. So that is the clear difference between the two. One is on mutable, one is on immutable, right?
Just
And in
mutable
this,
and immutable.
yeah, and in this case, there could be a situation of deadlock, like when we are using mutex and putting a lock on data type. Sometimes it happens that the lock is not released, and the program goes into a deadlock situation where the second user, even if the second thread or the second user is trying to access it, they are not able to access it because there is some kind of a deadlock situation that the other threads are not able to access it. Let
Uh,
me give you a real time
only
scenario where
only,
your,
only mutable got this problem, I think. Immutable don't have this problem.
yes, immutable won't have, only mutable will have that problem, you're right. So if real time example, have you ever faced it on your own laptop? You have a browser opened and when you click on some other window, the other window does not open. Have you ever faced such a situation?
In Windows, always face. In Mac, sometimes yes.
Yeah, I mean, okay, you're using Mac, so you might have not faced. Mac is still better, way better actually.
Yeah.
So
MacBook is good for working, but when you play games, that's not very good.
okay, I don't know about that. I hardly play games, but yes,
Yeah.
people who play games, they yeah tell that it's
And they
more
need Windows
playing.
play game because MacBook you always need to pay a lot of things, and then Mac doesn't design very good for advanced game.
Yeah, but I think so for memory management, Mac is very good. Windows system are a little bad in memory management, but then that's why the cost is higher for a Mac. So
And then but the MacBook when you sell to other people for second hand, right, the price is quite good. So it depends how you see. You buy with cheaper one, but you can't sell with a good price. But you buy the expensive one, but you sell it in a good price.
Hope this session was helpful for any programmer who is willing to learn Rust as a beginner. Next, we will cover more on Rust, so stay tuned for more. Make sure to subscribe to the channel and keep coding.